So the first thing we need to do to define the principle of incommensurability is to define the terms. Okay, so the claim I'm making is that all observable phenomenon in the universe at all scales can be explained and understood in terms of a single principle. Okay, so that's the claim I'm making. Thus, the principle of incommensurability can be thought of as a unifying principle. So I am using the principle and the fractal paradigm to unify, to define my unification principle. And so the combination of the principle of incommensurability and what I discovered by studying the fractal paradigm will allow me to do a kind of a unification much different than the way it is currently being done. So I am trying to unify the universe at all scales. I'm trying to unify all the scales in principle. So what is a principle? Okay, a principle is a fundamental truth or proposition that serves as the foundation for a system of belief or behavior or for a chain of reasoning. Okay, a chain of reasoning is a line of thinking. So I highlighted the important terms here. Principle is a fundamental truth. It forms a foundation, so it is a foundation of a chain of reasoning or a line of thinking. Okay, so what the principle is basically a line of thinking. It is my line of thinking. Actually, at least the principle as I'm going to define it basically is my line of thinking. And the foundation I have been laying down in all my previous videos. So all of the previous videos that I have put out are basically the foundation for the understanding of the principle. And so all the previous videos that I made actually help me understand the principle. And so if they can help me understand the principle, I'm hoping that if you watched most of my videos or several of my videos, that this will be much easier for you because I have already laid the foundation for the principle that as I'm outlining. So next we need to define the term incommensurability. Now, incommensurability, of course, comes from the word incommensurate. And incommensurate means to have nothing in common, impossible to compare. You could also use the term orthogonal. Now, orthogonality in mathematics means 90 degrees out of phase, but orthogonality in general means our two concepts or two principles that basically have nothing in common. So this is in general the term incommensurability. Incommensurability can come in many forms, and so it's just not one thing. For many things can be incommensurate in principle. Okay, and so we're going to look at many of these incommensurate principles as we move forward. The next term we need to define is the term conjugate, because the principle of incommensurability is about the conjugate relationship between incommensurate principles. So you can have two things that are incommensurate in principle, but they can be joined together, especially in pairs, coupled, connected, coexisting, or conceptually related. Okay, so conjugate principles are principles that have nothing in common, that are orthogonal to some extent, but the concepts themselves can coexist and are conceptually related. So, dielectric and magnetic, these terms are incommensurate in that the dielectric is not the magnetic and magnetic is not the dielectric, but these two ideas are conceptually related, and they can also coexist, as we know, in an electrical circuit. And so, so I've heard people use the term incommensurability or incommensurate and conjugate interchangeably, but this is not quite right. Incommensurate and conjugate are two aspects of the principle. Okay, they are two aspects. One aspect is that the two incommensurate principles are orthogonal. Okay, they have nothing in common. You can't compare them. But they also can be joined together in pairs. So incommensurate principles always comes in pairs. Okay, they can coexist. I'm going to give you an example right here of the complex plane where the real numbers are on the forward diagonal and the imaginary numbers are on the backward diagonal. The real numbers and imaginary numbers are incommensurate principles. All right, they're impossible to compare because you cannot measure a real number with an imaginary measuring stick and vice versa. Yet they can coexist in the 2x2 matrix quite nicely, and so they are connected. They can coexist. They are coupled by the virtue of the 2x2 matrix, and they are conceptually related because real numbers are numbers and imaginary numbers are numbers. And so this is basically the principle. These are the three main terms that need to be defined to understand the principle, including the term principle itself. So what I did was I started binning certain principles, certain words into incommensurate principles, and then trying to come up with a conjugate principle that conceptually relates the two principles. So there are many incommensurate principles. Each of them is the conjugate. Each one has one and only one conjugate. And so the conjugate relationships are, darkness and light are conceptually related. Silence and sound are conceptually related, but darkness and sound are not conceptually related. And so this is the meaning of the conjugate nature. So this is why incommensurability, or the concept of incommensurate, is not interchangeable with the concept of conjugate. So darkness is the conjugate of light, silence is the conjugate of sound, stillness is the conjugate of motion. But darkness and light are incommensurate principles, silence and sound, stillness and motion are incommensurate principles. So the incommensurability is in the binning process. It's in the finding two principles that are incommensurate, that cannot be compared, that are orthogonal to each other, but then making sure that they have a conjugate relationship of some sort. So darkness and light have a conjugate with illumination, and silence and sound have a conjugation with, something called music. Stillness and motion have a, propagation. Could be a conjugate principle, the principle that binds these two principles together. Okay, balanced, unbalanced, equilibrium would be the conjugate of balanced and unbalanced. So these are conjugates of each other, and this is the principle that binds them. Okay, noumena, phenomenon, observable, counter space, space, matter. Okay, sink, source, and flow. So flow is the principle that binds the concepts of sink and source. Okay, potential and kinetic. Well, energy is the concept that ties these two ideas together. Dielectric, magnetic, electromagnetism, of course, ties these two together. Tension and pressure. These are forms of force. So the concept of force conceptually relates tension and pressure. So these are all the conjugate relationships that are incommensurate in principle. Okay, so I just wanted to make it clear that the term incommensurate and the term conjugate are just two aspects of the principle, and those terms should not be used interchangeably. So that is how I define the principle of incommensurability. As I said before, nobody has actually defined the principle, and so I felt that it was, my obligation before moving forward with any discourse about the principle of incommensurability that I define my terms. So these are the terms that I define. This is how I define them, and in order to move forward, I needed to define my terms. And so now that you understand where I'm coming from in terms of the principle and the definitions, the definition of principle, incommensurability, and the conjugate nature of the principle of incommensurability, all of the rest of my videos will be about teaching you how to use the principle to help understand the universe. And so this is the line of thinking that I've been following for years and years and years, and just more recently had a few breakthroughs in my mind about how to explain this to you so that you can understand it the way I understand it. And so that is what I am trying to do. So in the next video, I'm going to talk about the incommensurate principles of counter space and space. These are terms that are used by Ken Wheeler and Eric Dollard, and although I'm not a big fan of these terms, I'm going to try to explain them to you from the perspective of the fractal paradigm. What I found was that these terms are much, much easier to understand in terms of the fractal paradigm, and so that is what I'm going to try to do in the next video. And so this is all I'm going to do for this video, and well, I guess I'll be back.